What lies beneath the surface of our planet? This question has always fascinated humans. In recent years, new technologies have allowed scientists to study the inner workings of the Earth like never before. The findings are amazing. We've discovered gigantic subterranean rivers, vast underground lakes, and even bizarre life forms that thrive in total darkness. In this episode, we will focus on one particular area, Yellowstone National Park. This park is world famous for its geysers, hot springs, and other geothermal features. But what most people don't realize is that there is much more going on beneath the park's seemingly barren landscape. So join us as we explore the stunning subterranean world beneath Yellowstone. Yellowstone National Park is located in the northwest corner of Wyoming and was the world's first national park. It's home to a variety of wildlife, including bison, elk, and wolves. But it's best known for its geothermal features, which include more than 10,000 hydrothermal vents. These vents range from small pools of boiling water to large geysers that erupt hundreds of feet into the air. The most famous geyser in Yellowstone is Old Faithful, which erupts every 90 minutes and can reach heights of up to 185 feet. The reason for all these geothermal features is the magma chamber that lies beneath the park. This magma chamber is part of the Yellowstone Supervolcano, which is one of the largest and most powerful volcanoes in the world. The supervolcano is about 43 by 28 miles, making it larger than the entire state of Rhode Island. If it were to erupt, the devastation would be catastrophic. The surrounding area would be covered in ash, and the entire United States would experience a volcanic winter. Luckily, the chances of this happening anytime soon are slim. The last major eruption occurred about 640,000 years ago. But while the risk of an eruption is low, there's another danger that exists beneath Yellowstone. There are so many geothermal vents that there's a constant risk of them becoming supercritical. A supercritical fluid is a substance that's under high pressure and temperature. When these conditions are released, the substance becomes supercritical and can cause an explosion. This is what happened in 1985 when the Cerro Tololo supercritical CO2 eruption in Chile released 1.6 billion cubic feet of CO2. Over 400 people had to be evacuated and several homes were destroyed. While a supercritical CO2 eruption at Yellowstone would not be nearly as destructive as a volcanic eruption, it would still be very dangerous. The CO2 would blanket the surrounding area in a thick fog, making it difficult for people to breathe. And while scientists can monitor the vents for signs of increased pressure, they can't predict when a supercritical eruption will occur. In addition to the risk of supercritical eruptions, there's also the potential for earthquakes to trigger volcanic activity. Earthquakes are common in the Yellowstone area. In fact, the largest earthquake in U.S. history, a magnitude 7.3 shaker, occurred near Yellowstone in 1985. While this earthquake did not trigger a volcanic eruption, it did release enough energy to cause changes in the magma chamber. These changes could potentially lead to an eruption in the future. To understand the potential impact of a supercritical CO2 eruption or an earthquake-triggered volcanic eruption, it's important to know how Yellowstone formed. Yellowstone is a hotspot volcano, meaning that it sits atop a plume of rising magma from the Earth's mantle. This plume of magma creates a magma chamber beneath the volcano, which is what fuels the geothermal features we see at the park. However, as the North American tectonic plate continues to move over the hotspot, the volcano will eventually exhaust its magma supply and become dormant. When this happens, the geothermal features will stop producing and the supervolcano will no longer be active. But while Yellowstone may eventually become dormant, it will not disappear. The magma chamber beneath the volcano will remain and will continue to produce geothermal features for millions of years. In fact, the remnants of Yellowstone's past activity can already be seen in the surrounding area. For example, the Absaroka volcanic complex is the eroded remnant of a magma chamber that was active about 1 million years ago. Similarly, the Lava Creek tuff is the solidified ash and debris from an ancient eruption that occurred about 640,000 years ago. These features show that even when Yellowstone's current magma chamber is depleted, the volcanic activity will not stop. Another interesting fact about Yellowstone is that it's not just a single volcano, but actually a complex of three: the Yellowstone caldera, the Mesa Falls, and the lava creek. The Yellowstone caldera is the largest of the three, and is what most people think of when they hear the name Yellowstone. However, the Mesa Falls and Lava Creek are also active volcanoes that could erupt in the future. One way that scientists monitor Yellowstone is by measuring the gases that are emitted from the park's hydrothermal vents. The most abundant gas emitted is water vapor, followed by carbon dioxide. Scientists also detect smaller amounts of other gases, such as hydrogen sulfide and methane. By monitoring the levels of these gases, scientists can get an idea of what's happening beneath the surface of Yellowstone. For example, if the levels of carbon dioxide suddenly increase, it could be an indication that there's more magma rising from the magma chamber. Another way that scientists monitor Yellowstone is by measuring the temperature of the various geothermal features. If the temperature of a particular feature increases, it could mean that magma is getting closer to the surface. Scientists also measure the tilt of the ground around Yellowstone to look for any changes that may indicate that the magma chamber is getting larger. Additionally, seismographs are used to monitor the seismic activity in the area. Any increase in earthquakes could be a sign that the magma chamber is getting more active. Despite these monitoring efforts, there's still a lot that we don't know about what lies beneath Yellowstone. The park is so vast and the terrain is so rugged that it's impossible to study the entire area at once. In addition, the extreme heat and pressure beneath Yellowstone make it difficult to collect samples from the subsurface. As a result, much of what we know about Yellowstone comes from computer models and estimates. One of the most exciting discoveries made in recent years is the discovery of a giant subterranean river beneath Yellowstone. This river is about 1 mile wide and 230 miles long, and is located about 6 miles beneath the surface. The river is thought to be formed by the movement of tectonic plates and is similar to other giant subterranean rivers that have been found around the world. The discovery of this river was made using seismic tomography, which is a technique that uses sound waves to create images of the inside of the Earth. The researchers who made the discovery believe that the river could be a significant source of water for geothermal features such as geysers and hot springs. Another amazing discovery made beneath Yellowstone is the presence of vast underground lakes. These lakes are located deep within the Earth's crust and are thought to have formed when magma chambers cooled and solidified, leaving behind pockets of water. One of the underground lakes is located about 5 miles beneath the Norris Geyser Basin and is about 800 feet deep. Another underground lake was discovered near the Upper Geyser Basin and is thought to be connected to the nearby Black Sand Basin. These underground lakes provide a unique environment for studying the interaction between water and rock. Researchers hope to learn more about these lakes in the future to better understand the geothermal features of Yellowstone. Yellowstone National Park is a place of great beauty and wonder. From its geysers and hot springs to its vast underground rivers and lakes, there is much that we still don't understand about what lies beneath the park's surface. But thanks to advances in technology, we are learning more about the inner workings of the Earth than ever before. Who knows what other amazing discoveries await us in the future? If you enjoyed this episode, please leave us a like and subscribe to our channel for more videos about the amazing world around us. You can also check out our other videos, which explore topics in science, nature, and technology. Thanks for watching. See you next time.